All right, so look now. I'll be using this calculator to punch the figures. So 1 divided by, let's start with the conclusion. 1 divided by 5. 1 divided by 5. I have 0.2. So you have 0.2. 1 divided by 2.5. I have 0.4. 1 divided by 1.5. 1 divided by 1.5. I have 0.67. 1 divided by 1. I have 1. Okay, so let's do for this other next one. 0.238. 1 divided by 1 divided by 0.238. I have a 4.2. 4.2. 1 divided by 1 point, 1 divided by 0.166. I have 6.02. What's the next thing there? 1 divided by 0.126. I have what? 8.0. The next one is 1 divided by 0.098. I have what? 10.2. 10.2. Okay, again you do it again for this one, do it again for this one, do it again for this one. So let's just continue. 1 divided by this, 1 divided by 0.164. we have what? 6.08. 1 divided by 0.103. what do I have? 9.7. 1 divided by 0.086. I have what? 11.63. Are you getting it? Then this one now. 1 divided by 0.067. I have 14 point. That is 15.0. Are you following it? All right. So let's do for this last one. Then we'll do for this one also. So 1 divided by 0.126. I have 8.0 again. 1 divided by 0.090. I have 11.1. What's the next thing there? 1 divided by 0.070. I have 14.3. Let me approximate it. Then this last one, 1 divided by 0.052. I have 19.2. Okay. All right. So let's come to this last one now. Let's come to this last one, and so that we can, after now we now calculate our slope. I say our slope, our scale. So 1 divided by 0.085. I have 11.76. Then 1 divided by 0.064. I have 15.6. 1 divided by 0.046. I have 21.7. What is the next thing there? 1 divided by 0.036. What do I have there? 27.7. 27.7, or let's say 27.8. Okay, so if you notice this question, when it was given to you in this format is just to throw you off balance, like you don't know what to do. So what do I say? I said that this column here, it won't appear on your table. That is the first thing you need to know. Where this column will appear is on the top of the what? Of the figures there. Are you getting it? So this column is for the substrate concentration. That just repeating. This thing is just arranged scatteredly. So you will now arrange it again. So if you notice, I take out the concentration. This. They're always repeating it. 5, 2.5, 1.50, 5, 2.5, 1.50. So I just take it as 1. Then I put the velocity. The velocity for this first one is this, Abi. So I put it there. The velocity for the second one, this. I put it there. The velocity for the third one, this, right? Then I put it there. And then for the last one, this. I put it there. You understand? Very, very simple. Once you can arrange it in this format, the next thing is to take the inverse of them. Then you plot your graph straightforward. You get now? Alright, so how do we get the scale for this now? In like manner, like I said, the scale is usually what now? The scale, let's say for the scale for the y-axis, already in your graph sheet, you should have, at the top of your graph sheet, you should have put something like this. It's always constant, 2 cm to what? To a particular unit of which you don't know for the y-axis. Is that not so? While for your x-axis, you should have put something like this, 2 cm to a particular unit. You don't know it yet. You understand now? Alright, how do you get the unit? How do you get the scale? Already we know that for the graph. Let's look at this graph. Okay, although this is not the kind of graph they will give you. The graph they will give you is that blue graph that is having small bursts. You understand now? Alright, so listen now. Let's assume you want to start from this point here like this. I get my point. I'm starting my graph at this point, so I will just quickly rule. I'll quickly rule now. Once I convert the table, the next thing I'll do, I'll just create my graph there like that first. So I will just rule now. So I will rule. I get my point. So this is it. So what's the next thing you do? You rule this other side. Okay. All right. So once we're done with this, here will be 0, right? Then we'll put something here. We'll put something here. We'll put something here. We'll put something here. Then also put something here, like that, like that, like that, like that, to the end. In like manner, we'll put something here. 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 Okay. Now what am I trying to say? Once you are done with this table work, everything, just rule your graph like this. It's fairly constant. Rule it like this. What is the next thing you need to do now? Okay, let's put the scale here. Let's put the scale here. I say y axis. Where is there? 2 cm to a particular unit, right? S axis 2 cm to a particular unit, right? We don't know the unit. How do you get the unit? Like I explained yesterday, I said you get the unit from a range of possible scales. A range of what? Possible scales. So let's say for the y axis now. For our y axis, we get the unit from what? We say the highest value. The highest value is that also all over what? A range of what? Possible scales. A range of possible scale. So this possible scale now, okay, what's the highest value there? What's the highest value for the y axis? Remember, everything here in this place I'm circling is the y axis. Only this one is s axis. So you will take into cognizance of everything here and look for the highest value, of which if you are vigilant, you will notice that this is the what? Highest value here. So I will take it there as what? 27.8 is my what? Highest value. Then divided by a range of possible scale, of which I said the range of possible scale could be 1, 2, 5. Then if you go higher, 0.1, 0.2, 0.5. Then if you go higher again, 0.01, 0.02, 0.05. Let's stop here. All right. So how then do you get the scale? Look at it now. We'll take 27.8. I will be trying it with all these values. The one that give me the required numbers of bus, of which we know that the bus for the y-axis is about, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9. So once you can get like 7, 9, 10 buses, you are good to go. You get it now. All right. So let's proceed. Something like this: 27.8 divided by, let's try 5. So 27.8 divided by what? 5. I have 5.56 bus. Okay. I'm looking for like 7 buses. Are you getting my point? So let's try this one out first. Let's try this one first. So 27.8 divided by 2 is giving me 14 buses. 14 buses. Okay, let's assume I want to work with this. Did I have up to 14 buses here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I don't even have up to 14 buses there. I don't have up to 14 buses there. I don't have up to 14 buses. So how do we move? Because if we are to go with this one will be too higher now. You understand? So our scale is either 2 or 5. Either 2 or 5. So for the sake of this thing now, I will assume I want to use a value between those two. So let me say let's say I want to try 4. Although 4 is not in this possible way now, but let me just try 4, because I don't want to work with 5 buses. I get my point. I don't want to work with 5 buses. If I want to work with 5 buses, it will be like, hello, it will be like 1, 2, 3, 4, 5, and the graph will be too small. So in this case now, we generate another value that is in between 2 and what? 5. Because if I work with 5, it's 5 bus. If I work with 2, it's 14 bus. And I don't have up to 14 bus here. So what will I do? I will generate another value. Let's say I try 4. So 27.8 divided by 4. So it's giving me 7 buses. 7 buses. Okay, 7 buses is still okay. So let's work with 4. Let's work with 4. Let's go with 4. We're going with 4 now. We're going with 4. Okay. Let's try 4. Let's try 4. And I've said we should go with the 2 sha. But okay, let's assume I go with 2. If here is 2, 4, 6, 8, 9. Okay, 2, 4, 6, 8, 10, 11, 12. 12. What is the next thing there? 8, 10, 12. What is the next thing after 12? 14, 16, 18, 20, 22. All right, I'll go with the 2. The only thing is that I won't be able to plot this one. This one I will just take it as an outlier. I get my point. We'll take it as an outlier. I don't want to mess up my graph. I'll go with 2. So I'll go with 2. So here will be 2 units. Okay. So here will be what now? I will have 2. I will have 4, I will have 6, I will have 8, I will have 10, I will have 12, I will have what? 14, I will have what? 16, I will have what? 18, I will have what? 20, and I will have 22. The only thing that will not appear on the graph is actually this last one, and I will take it as an outlier. I don't want to spoil my graph. I want my graph to be long. You understand? All right. What about the S-axis? How do we get the S-axis now? How do we get the S-axis? In like manner, I said you use the range of possible scale of which what's the highest value for the S-axis? The highest value here is 1, right? So for the S-axis, the highest value will now become 1. Okay, let me not cancel that. Let me just put it here. 1 divided by a range of possible scale, right? All right, let's try 5. 1 divided by 5, 0.2. I mean, 5 cannot be my scale. Let's try 2. 1 divided by 2, 0.5 cannot be my scale. If you try 1, it's going to give you 1. It can also be my scale. Let's try 0.5. So 1 divided by 0.5, that is 2. That is too small, but it's too small. Let's try this other one, 0.2. 1 divided by 0.2, that is 5. Okay, 0.2 is also okay. Let's try this one. 1 divided by 0.1, that is 10. So we all go with 0.2. 0.2 is my preferred scale on this case now. So look at the graph now. I'll quickly come to this place. What will I put here? 0.2. What will I put here? 0.4. What will I put here? 0.6. What will I put here? 0.8. Then here will be 1.0, then 1.2. All right, very easy something. All right, we've gotten the range of the scale now. We've gotten our scale. Just to add, this side will be negative, so negative 0.2. In case we want to get our km from this place, negative 0.4, and here will be what? Negative 0.6. Okay, this is our graph now. Let's plot it now. Now, when S was, I want to plot this against this now. Okay, I want to plot this against this. When S was 0.2, your Y was what? 4.2. So when S was 0.2, 0.2 is this one. Is that not so? This is 0.2. S was what? 4.2. That means it will be between 4 and 6, right? So how do I know where it is? With the scale for the Y-axis is what? Is 2 units, right? While for the S-axis is 0.2 unit. So let's divide 2 by 10 so that we'll know what one small bus stands for. 2 divided by 10, we get what? 0.2, right? Meaning one small bus is 0.2. So if I should move from here, will be 4.2. What am I looking for? 4.2. That means this is the place here. Are you seeing this thing? All right. So here's a 0.2, 4.2. So I will plot it here like this now. 4.2. All right. The next thing now is when S was 0.4, our Y was what? Or when Y was 6.02. This is 6. This is 6, and here will be 6.2. So let's assume it's 6. When Y was 6, it was what? 0.4. Okay, and Y was 6 was 0.4. I'll plot it here like this. Are you seeing it? All right. Then what's the next thing? What's the next thing there? When it was when Y was 8, it was what? 0.67. When Y was 8, it was 0.67. Here is, we know that one small bus for this side will be what now? Since the scale for the S-axis is 0.2 divided by 10, you have what? 0.02. So let's add. Here is 0.6. What am I looking for? 0.67. 0.67. So if I should add 0.6 plus 0.02, so I'll get 0.62. So here will be what? Here will be 0.62. Here will be 0.64. Here will be 0.66. Then here will be 0.68. So it's in between this line. Are you seeing it? All right. So it is 8 there on the y-axis. 8. Yeah, on the y-axis 8. So we just trace it up here. 0.62, 64, 66. Then yeah, this is where it is here on the graph here. This is the point on the graph. All right, God being too kind. We've plotted three points now. Let's move forward. Then when it was 10.2 already, you know it will be this point. 10.2, it was 1. So this is the 10.2, it was 1. So I'll plot it here like this. This is it here. This is the point. All right, God be too kind. Let's view this graph. Let's view this graph. Straight line graph. On the straight line. Are you seeing it? Those 3 points are entering the graph. This point, let's put it away. This point, that point, and this other point. The last 3 points enter the graph. Are you seeing it? So we have things like this. So So that is it. I get my point. All right. So once we're done with this now, what do I do now? I will label this graph, right? This graph was for what? Uninhibited. So I will just call it U. Uninhibited. Do you understand? I will come to this top here. I will say where U stands for what? Uninhibited. All right. God be too kind. We're done with the first graph. Moving forward to the next one now. I will now plot this against what? This. Is that not so? I'm going to plot this as it against this one. Again, when y was 6.08, it was what? 0.2. Here is 6.08. Here is 6 point. Okay, it will just be like half of this place now. All right. So your s was what? 0.2. So I'll just take it there like this. Your plot here like this. Yeah, that is it. All right. Now, when the next one is what? 9.7, which is almost 10, right? So 9.7 is almost 10. So it will be close to this place here. 9.7 is almost 10. So yeah, I'll just assume it's 10, so that I will not waste my time. It was 6. It was what? It was 0.4. So 0.4, 9.7. You just below 10 small. So you put it here like this. Put it here like that. Are you getting it now? All right. Then when it was what? 11. Are you seeing this thing? Can you see? All right. So when it was 11.63, that's almost 11.7 or 11. Okay, let's tell me it's 11.6. So let's just look for it. Yes, here is 10. Here is 12, right? And we said one would be what? Let's say 2 divided by 10. That is 0.2. So it will be 10.2, 10.4, 10.6, 10.8, 11. What am I looking for? 11 point what? 11.63. Okay, 11, 11.2, 11.4, 11.6, 11.8. So I will assume it's 11.6. Then where am I going to plot it? It was what? 0.67. Okay, that is the same point, right? So I will trace this one up. And I'm going to plot it here. This is the point here in which we plot it. Okay. All right. What's the next thing now to do? What's the next thing there? The next thing now is to okay. When it was 15, it was 1. So where's your 15? Where's your 15? So 15 is where? Okay. Here's 15 will be. Here's 14 will be half of this, Abi. Yeah. It was 1. So we'll trace 1 to that point. 1, 2, 3, 4, 5. So this is half of it. So this is it. Are you seeing it? All right. So I've plotted the second graph now. I'll just quickly rule. This graph, not the entire. No, it's not TV. Okay. I think there's a mix-up somewhere. The graph is not entering. Alright, so I'm coming. Let me assume I want to assume all of them are coming this way. Okay. And if you have to plot it like this, it won't make sense. So under this case now, this thing is not entering, but it's not something that you waste your time in exam condition. Just try and, in a way, put it to the other side. So let me just assume I want to rule like this. I'm assuming I'm running it like this in a way, sure. So I want to believe this is how the graph will come. I get my point. I just use 2 points, although 2 points is not so accurate, sure. But for this case now, since the okay, I think we can even work with 2 points since we only have 4 points. We only have 4 points. So if you take the average of 4 points, it's 2 points. So let me work with the 2 points and put it here like this. I get my point. Alright, so this is it. What do I do next? I will label this one as what? As inhibition what? This is the first one, so inhibition 1. Is that not so? Alright, so draw the other one now again. Draw the other one. Now again, if the graph is not entering, just find a way to make sure that all of them in a way meet at a particular point. Or if you notice that all of them are heading towards a particular point, just put it like that. Just put it like that. So that you not waste your time. What's the next thing? What's the next thing? I want to plot this against this, right? So I'll plot this against this. When it was 8, is our 8, it was what, 0.2. So I'll quickly plot here 0.2. Then when it was what? When it was 11, it was 0.4. Here's a 11. 11 will be half of this, Abby. So it was 0.4. Then when it was 14.3, it was what? 0.67. 14.3. Yes, 14.2. So 14.2 will be half of this place, right? So it was 0.67. So I'll just trace this place up. What am I looking for? 14.3. So 14.3 will be alright. 14.3 will be this point, right? This is it now. Go to that point there. Then the last one is waiting 19.2. It was 1. 19.2. 19.2 will be somewhere up here. So here is 19. 19.2 will be the next point there. So this is 19.2. So it was what? It was 1, right? It was 1. So I will just trace it to 1. Then there's a 1, 2, 3, 4, 5, 6. Okay. This is the point here. Alright. So let's draw this one quickly. Again, if you notice, all of them are heading towards this point. Are you seeing it? Hope you are seeing. Alright, so I will just plot it like that. I will make sure that all of them meet at that point, because that is what is happening here on this graph. Because at the end of the day, they are not going to check your how do I put it now? Your figures. Last what they will check. So this one now, you can also put it like that. And you get my point. So I've plotted 3 now. So what's the next thing now? Let's plot the last one, right? So when it was 11.76, it was 0.2. So here's your 11.76. 11.76. 11.76. 11.76. This is here is 11. 11.2. 11.4. 11.8. So we have to assume it's 11.8. It was what? It was 0.2. So I'll plot it here. 11, 11.2, 11.4, 11.6, 11.8. Okay, it will be up here like this. Sorry, let's take it up a little bit. Alright, then when it was what? When it was 15.6, where's the 15.6? 15.6, it was 0.4. 15.6, here is 15, which is half between 16 and 18, right? So 15.6, 1, 2, 3, 4. Okay, here is 15. 15.2, sorry. Here is 15. It's not 15, yeah. Here is 15. So here is 15.2. Sorry, 15.2, yeah. 15.4, 15.6. This is it. Then what was it? What was it on the S at 0.4? So 0.4. This is the point here to plot. Alright. Then when it was 21.7. 21.7. Here is 21.7. 21.7. Here is 20. Here is 20.2. 20. Okay. Here will be 21, right? So here will be 21.2. 21.2, 21.4, 21.6, 21.8. So I'm looking for 21.7. That should be half of that, right? Okay, then it was what? It was 0.67. 0.67, which is this point. Let's trace it up there. So it will be somewhere here like this. Okay, it will be somewhere here like this, and that 21 points. Okay, here it is. Here it will be this point here. All right, so if we're done with this now, the last figure is there, which is 27.8, but I can't plot it here, so I will just mago this thing in a way so that all of them will meet at a particular point. Are you getting it? All right, just put it like that. This is what I did. All right, although I took only 2 points, but roughly, all of them is heading towards 1 point. So just find a way and put it like that. All right, so if this one is clear to this point now, I've plotted the 4 graph, right? This one is I2, inhibition 2, then what inhibition what 3. Now, if you notice, all of them are meeting at a particular point on the S axis, right? On the S axis. This point in which they're meeting means that they have the same Km. And when an enzyme is having the same Km but different Vmass, what kind of competition is that? That should be non-what? Competitive. Is that also non-competitive? So let me just put it here. Non-competitive. Okay, I think you won't see it there. Let's put it here. So that kind of inhibition whereby all of them, or at least all of them, are meeting there now. So they're meeting here like this. Is that also all of them are meeting here? Means all of them is showing non-competitive inhibition. Non-competitive inhibition. So this is it. Then what then do you do? Once you are done plotting this graph now, the next thing you will do is to calculate your kinetic parameters. So I will do that one in the next video. So this thing has been tinted. So let's